All right, this is Algebra 2 reviewing for our first semester final. Today we will be simplifying radicals. So for our first example here, we have the square root of 108, x to the 5th, y to the 7th. So when we have the square root of this, we need to think of our list of perfect squares. So 4, 9, 16, 25, 36, 49, etc. And we want to find the largest perfect square that divides in evenly to 108. In this case, it happens to be 36. So we're going to split 108 up into the square root of 36 times the square root of 3. The square root of 36 we know is 6. Now we're going to start looking at our variables here. This one is an x to the 5th. And since we're doing the square root, we go, okay, 2 fits into 5 twice, so we have an x squared. And we know we're going to have 1x left over inside of the square root. Do the same idea with y to the 7th. 2 fits into 7 3 times, so y to the 3rd. And we know we'll have 1y left over in the square root. So then we have it times the square root of our 3xy. So that is the square root of 108, x to the 5th, y to the 7th, simplified. Cubed root of 54, x to the 8th. So cubed roots means that we have to think of our perfect cubes. So like 8, 27, 64, and so on. 54 is the cubed root of 27 times the cubed root of 2, because 27 times 2 is 54. The cubed root of 27 is 3. When we look at our variables, 3 goes into 8 twice, so x squared. And then we are left with the cubed root of 2, and we had 2 leftover x's, so x squared. So this is 3x squared times the cubed root of 2x squared. And once again, this x squared here was because 3 went into 8 twice, and we had 2 left over. Next one, 18 square root of 72 plus 2 times the square root of 49. Well, the square root of 72 has a perfect square of 36. So we'd have 18 times the square root of 36 times the square root of 2. And then 98 is the square root of 49 times 2. So we know square root of 36 is really 6. So this is now 18 times 6 times the square root of 2. Plus 2 times, we know the square root of 49 is really 7. So 2 times 7 times the square root of 2. 18 times 6 is 108. So this is 108 square root of 2. Plus 2 times 7 is 14. So 14 square root of 2. The square roots of 2 are alike. So we just have to add 108 plus 14, which is 122. And then square root of 2. So that's simplified. Next up for radicals, we could also have something like this. Negative 3 square root of 2 over the square root of 3 minus the square root of 5. To simplify this, we're going to have to multiply top and bottom by the conjugate. So in this case, the conjugate would be the square root of 3 plus the square root of 5. So in the denominator here, this involves foiling. So square root of 3 times square root of 3 is square root of 9. Square root of 3 times square root of 5 is plus square root of 15. Negative square root of 5 times square root of 3 is minus square root of 15. Negative square root of 5 times square root of 5 is negative square root of 25. Numerator, we just have to distribute. So negative 3 square root of 2 times the square root of 3 is negative 3 square root of 6. Negative 3 square root of 2 times the square root of 5 is negative 3 square root of 10. We can simplify our denominator still. Square root of 15 cancel. Square root of 9 is 3. Square root of 25 is 5. 3 minus 5 is negative 2. So right now we have negative 3 square root of 6 minus 3 square root of 10 over negative 2. But we know that we do not keep negatives in the denominator. So we would times top and bottom by a negative 1. So that leaves us with 3 square root of 6 plus 3 square root of 10 all over 2. And that would be our simplified answer. And last but not least, we have the cubed root of 7x over the cubed root of 3y. Since this is a cubed root, we need to make the 3 into one of our perfect cubes. So 8, 27, 64, and so on. Well, we know that we can make the 3 into 27 by taking 3 times 9. So here we're going to times this by the cubed root of 9. And then y, we want it to be to the third power. It's to the first power right now, so we're going to times it by y squared. That way, we would get a total of 3y's. If we multiply that by the denominator, we better multiply that by the numerator. So then in the denominator, we would have the cubed root of 27y cubed. In the numerator, we would have the cubed root of 7 times 9 is 63, and then xy squared. We know that the cubed root of 27 is 3. Cubed root of y cubed is y. And then 63, you look to see if you can simplify it. Any perfect cubes go in there, and none of them do, so it stays the cubed root of 63xy squared. So there's your quick review on radicals.